Hey everybody, today we'll be discussing the Leetcode Sunday contest, problem number 3. So let's get started with that. Okay, so the problem says that we want to count the number of bowl subarrays, right? And yeah, so basically what we want to do is like, like your array, and it's called a bowl if, let's say, you have two elements like this, and all the elements, like this is the minimum element, right? So all the elements which are below this, like, and below this, uh, right, so below this line basically, uh, so basically you should not have any elements over here, right? So because these are the two ends of the bowl, okay? So if you have an element over here, let's say, okay, and you are claiming that these are my two ends, so this cannot be a bowl because this element, this guy, is greater than this guy, right? So the condition of a bowl is that all the elements in between these two ends should be strictly less than the lesser end of the bowl, right? So so if you get an element like this and you're trying to choose this end, then it's not a bowl. Okay, so basically this observation says that the number of bowls is linear in the number of elements. So number of bowls is kind of like O of n complexity, right? That's the number of bowls. It cannot be quadratic. O of n square is not possible, right? Because there can be at max one end for every end that you choose, right? So basically this gives us the idea of the problem, like how we want to approach it. And once again, I'll just reiterate, like, for example, I'll just take an example, okay? So let's say this is 4 and you got 3, 1, and then you got 5 and 6, right? So now your array looks like this. You got let's say 1, 3, 4, 5, 6, okay? So you got a 4, 3, 1, 5, 6. So how many bowls does this array have? So number of bowls is obviously like, okay, we'll choose this minima. So we go like this and we make this bowl, okay? So this is one bowl, okay? And can this be a bowl? Can this guy be a bowl? It cannot be a bowl, right? Because we are claiming that the entire subarray is a bowl, but the ends are this 4 and 6, right? But there exists an element in between 4 and 6 which is 5. So 5 is greater than the minimum of 4 and 6, right? So that's why it's not a bowl. And that's the reason why as I stated earlier, the number of bowls is always going to be linear, right? So you just have to find, basically, if this is x, then you have to just find the first number which is greater than or equal to x, right? The second number will not be like part of the bowl. That will not be part of the bowl. So this brings us to a observation where we can use a stack. So basically you have number x, all the elements in between are less than x, and this element is greater than x. Since I think in the problem it's mentioned that all the elements are distinct, right? So yeah, that view you can do, like, it's distinct. So all the elements are in between are less than x, and the element of like this end, let's say it's a y, should be greater than x, right? We don't care what is happening over here, right? Because this is one possible bowl for us, okay? And I think the other tricky part was that okay, this you're just considering the left and right ends, right? But there can also be right and left ends. So for example, if x is over here, all the elements here are less than x, and you have a y over here which is greater than x, right? So this can also be a bowl. You have to see in the left direction and also in the right direction. There can be two ends, right? And yeah, so two ends, like this two end thing is also pretty evident. So I'll just give one example. I think the first test case is a good example of having two ends, 2, 5, 3, 1, 4, right? So you have, let's say, a 2, a 5, a 3, a 1 and a 4, right, like this. So what's the first end of the ball? It's this one, this and this, okay. And the second end is, so this is the first ball, okay, and the second ball is this. The first ball, the endpoints are this and this, and then in the second ball also the endpoints are this and this, okay. So now let's say so basically we obviously use a stack because it's a next greatest element pattern. So we would use a stack, which is a standard problem. But the thing is, like, let's walk through this example, okay. So let's say you have 5 3 1 4 2 5 1 3 1 4. So what's the next greatest element for this 3? It's this 4, right? And are there, like, the distance between the next greatest element index and the current element, is it like greater than 1? So you should have at least one element in between, right? As it's stated in the condition that the ball size is at least 3. Okay, so you just put that check. So here the answer will be just +1, like we'll just do increment 1 to the answer, number of ball, okay. And what else? And for 5 there is no next greatest element. For 2 the next greatest element is 5. So but there is no element in between, so there cannot be a ball over here as well. For this we already incremented 1. For this guy the next greatest element is 4 again, but there is no element in between, so again no answer would be incremented over here. And there is no next greatest element for this guy, okay. But now you see in the reverse direction, what's the next greatest element for 4? It's 5, right? So that's why you form a ball. So you just add an answer over here. Now you're iterating like this. So that's why we need to iterate in both directions. So now total answer would be 2. For any other, like, it's not possible. So for example, what's the next greatest element for 1? It's 3. So it's just, there's no element in between. So again no answer. Again no answer for 3, no answer for 5, no answer for 2. Right? So total answer is 2 as given in the output. So we have to iterate in both directions and find that element. So that's what I've done. Just took a stack and I'm following the next greatest element pattern in both directions. So basically there's a trick where you can find the next greatest element in both directions in a single loop. You don't have to run 2 loops to calculate the L and R arrays, right? Okay, so and then what I'm doing is, okay, I'm just calculating the L and R arrays and I'm just iterating on the L and R arrays again. So let's say if that is R of I is -1, so basically there's no next greatest, there should be a next greatest element and the number of elements in between should be greater than 1. So I just insert the endpoints of the balls, right? Because I'm iterating in both directions, I don't know if I will double count the endpoints. So it's better to have a set and to count the endpoints, right? And same thing I'm doing in the left direction. And then I'm just returning the size of the ball. That's it. Okay guys, thank you for watching, and if you have any comments, please feel free to ask, and thank you.